Hello, everyone. Welcome back to Apex Science Academy. This is the week 8 physics problem. And the idea is to plot a velocity and time graph, which we call VT graph, that describe the kinetics of one-dimensional motion. Okay, so let's get through it. The first step of graphing is to see what the coordinate system you're going to establish. And in this case, it's Cartesian coordinate. And so we have a horizontal axis that represents time, okay? And we have a vertical axis that represents the velocity, okay? And remember, in this case, time is only positive, so we omit the negative x-axis in this case. But the velocity is totally possible to be negative, so just go down a little bit, okay? So let's trace out the velocity profile as a function of time. We'll trace the velocity as a time dependence. So start with zero velocity over here at t equal to 0, velocity equal to 0, okay, and accelerate from stop to a speed of 60 miles per hour in 30 seconds. So my first key points is 3 seconds. Put a second. And in physics, and in most of the science journals, this is how you represent your axis. You label the meaning of your axis, and you also need to put a parenthesis and put down the units you're using. And I would like you to familiar yourself with it and even use it the format of labeling axis. Okay, so now at 3 seconds, the speed would be 60 miles per hour. So I'm using miles per hour as my axis. Okay, so that's the first, that's a very key point. And then it takes, maintain the same speed, which is 6 miles per hour for half a minute, meaning there's 30 seconds over here. All right, so it's 30. You see my drawing is not absolutely up to scale, but if you like to do it more precise, you might want to use a graded paper, or you may do a little bit better estimation. But this is the speed it takes. Okay, and we know for sure during this time, the speed is maintaining a constant. Okay. All right, so then it hits brake and takes 10 seconds for the car to come to a full stop. So the next key point would be 40, okay? And we know that it's going to be 0 again. So now in between this point and this point, it is acceleration. The easiest way to do that is by linking them directly, okay? So that means the car is going to accelerate at a constant rate. But the problem didn't say exactly it's constant rate or not. So you're completely free of doing something like that or something like that. It's all possible solutions. Similarly, when it hits a brake, it could decelerate at a constant rate, or it could do something like this or this, right? Both are possible. Okay, so in the end, this is our solution. It's a very simple graph. It's called a VT graph. And what you're seeing here is a velocity as a function of time. Again, if you're not familiar with the idea of a function, it's simply saying at any given time, there's a velocity. And you can learn the concept of function either through our MO1 class or just looking into some pre-calculus textbooks. Okay, that's about it. Thank you very much, and see you next week.